An astronomer holds a small circular disc at arm's length which just covers the full moon. If the disc is 2.6 millimeters in diameter and the distance from the disc to the student's eye is 28.8 centimeters, calculate the distance to the moon using the diameter of the moon as 3,475 kilometers. Well, answering this question, we know that the ratio between the diameter of the disc and the distance from the student's eye is equivalent to the ratio of the diameter of the moon and the difference to the student's eye. So the first thing we need to do is work out the ratio between the student's eye and the disc. Now the issue here is that they are both in different units. We've got centimeters and millimeters, so I'm just going to convert my centimeters into millimeters, by multiplying it by 10. So now we can think about it like this, that the equivalence between the diameter, the ratios equivalent between the diameter and the distance are the same. So the diameter of the disc was 2.6 millimeters and the distance was 288 millimeters, and that would be exactly the same as the diameter of the moon, which is 3,475 ratio to the distance. So what do we need to do to get from 2.6 to 3,475? Well, we need to multiply by 1,336.5 or so. So we're going to do the same on the other side, and if we do that, we get 384,923. So the equivalence distance to the moon would be 384,923 kilometers. An astronomer estimates that the ratio distance to the sun divided by distance to the moon is 394. The distance to the moon is 384,000 kilometers. Calculate the distance to the sun. So again, we can note the ratios between those would be the same. So we know that x, which would be the distance to the sun, divided by the distance to the moon, would be 384,000 equals 394, just by substituting the numbers into our equation. So we bring this over here by multiplying by 384,000, which gives us 151,296,000 kilometers. It does ask us to give our answer in standard form, so we will do it to 2 decimal places. So 1.51 times 10 to the, think about the decimal point being here, so we're moving it 1, 2, 3, 4, 5, 6, 7, 8 points to the right. So it'll be 1.51 times 10 to the 8 kilometers. A teacher uses data to calculate the ratio of distance to the moon divided by the diameter of the moon equals 111. The teacher knows that the diameter of the Earth is 12,740 kilometers, and it is approximately 3.5 times larger than that of the moon. So we haven't been given the diameter of the moon here, but we have been given enough information to work it out, because we know it's the diameter of the Earth and that is 3.5 times larger than the moon. So the first thing we want to work out is the diameter of the moon, and to do that we're going to take the diameter of the Earth, 12,740 kilometers, and divide it by 3.5 to give us 3,640 kilometers, and that's our diameter of the moon. And then we can just substitute into the equation. So d is the distance to the moon we're trying to work out, divided by the diameter of the moon, which we worked out here is 3,640, equals 111. So to bring this over, we're going to multiply it. So doing that gives us 4,04040. So we need to give our answer to an appropriate number of significant figures. So I would try and do the same as what is in the question. So in the question here, they've used it to 4 significant figures, so we'll do the same. So 404,000 kilometers. An astronomer estimates that the ratio distance to the Sun divided by diameter of the Sun equals 109. It tells us the distance to the Sun is 1.51 times 10 to the 8 kilometers. That's our distance to the Sun. And that divided by the distance, so the diameter of the Sun, which is what we are trying to calculate. So we'll call that x, equals 109. So now what we need to do is we bring the x over by multiplying it and bring the 109 by dividing it. So we get 1.51 times 10 to the 8 divided by 109 equals x. And if we work x out, we find out it's 1385321. So give your answer in standard form and to an appropriate number of significant figures. Well, again, we're going to use what they use here. So 3 significant figures. So it'll be 1.3. So 2 significant figures. And our next number 8 will become a 9 because the number after it is 5 or more times 10 to the 1, 2, 3, 4, 5, 6 kilometers.